Let's differentiate two functions taking full advantage of linearity. So this first function, f prime of x, it is by definition the derivative with respect to x of the function f of x, right? I'm looking for the function that gives me the slopes of my tangent lines. I'm looking for the rate of change of f of x. So when I differentiate f of x, that's me differentiating 3x to the 7 plus 2x cubed minus 5x. And I use linearity to my benefit. That means that I can distribute this derivative across that addition sign and that subtraction sign. So I can differentiate each piece separately. And I can also use the second part of linearity. That means that I can take constants out. So with that in mind, differentiating this function is really no more complicated than differentiating x to the 7, differentiating x cubed, and differentiating x. Right? I took this derivative operator and I sent it to this term, and that term. Right? Everything that was a constant was pulled out. The only thing that I'm now left with is the derivative of a bunch of power functions. So what is the derivative of x to the 7? The 7 comes down. And subtract 1 from the power is now 6. What is the derivative of x cubed? The 3 comes down. It's now x squared. What is the derivative of x? So you can kind of think x to the 1. So that's going to differentiate to the 1 comes down. You've got x to the 0 now, but anything to the 0 is just 1, right? If you think about the identity function, y is equal to x, your tangent lines all have a slope of 1, right? The derivative of x with respect to x is just 1. Okay, so the calculus is over, right? We've taken all the derivatives. I no longer have any derivative operators in my equation. Now it's just algebra. What is 3 times 7? 21. 2 times 3, 6. And minus 5 times 1, minus 5. So notice this derivative right here is us just differentiating this function, right? 3x to the 7. The 7 comes down, hits the 3, becomes a 21, x to the 6. 2x cubed, the 3 comes down, hits the 2, becomes 6x squared. Minus 5x, just minus 5. All right, let's work on this one. And I won't go through the all the details like I did over here, where I distribute the derivative operator to each term in the sum, and then I pull out constants. We'll just skip to the end, and we'll kind of do the shortcut where you don't actually have to think about all that stuff. First, before we differentiate, let's rewrite the function so that I can use a power rule. 5v cubed is already in power function form. But that fourth root of v, let's rewrite that as v to the 1/4. Now, y prime of v is the derivative of y with respect to v. So my first term differentiates to 15v squared. The second term differentiates to 1/4 v to the minus 3/4. Let's clean that up just a little bit. This is 15v squared minus 1/4. And then v to the 3/4 down in the denominator is the fourth root of v cubed. Right? But you were done at the calculus at this stage because you've taken all your derivatives.